Hi, hello
Hello.
everyone, and
Hello, everyone.
welcome to this webinar. We'll give another minute for people to join us, and then we'll get started. How are you, Ole?
I'm great, thanks, Laurent. How are you?
I'm great, thank you. So we are live from Stockholm, right? And
Live from
you?
Stockholm, sunny and cold Stockholm. Finally getting some winter. It's been very warm here, but now getting those freezing temperatures that we all long for in the north. How about
So
you?
I could almost say the same for Boston. Uh, we don't even know what zero means in Celsius these days because we've been I mean maximum was more like -5
Oh, wow.
like this and
That's
minus
really.
15
Is it
minus
windy too? Because that can make it a lot worse, I guess.
yep.
Mm.
That's the
Okay.
thing with Boston.
Yes, it is. No, we've had less wind actually, so it's been
Hmm.
quite beautiful. I'm a fan of winter, so I mean, maybe that's why I live up here. So I kind of prefer to have like real winters for at least a couple of months. Although the darkness can be dark, but if you have snow, that also helps.
So I knew there would be one guy that would love this type of winters, and you are the one.
I am the one. I'm here to promote winter. If nothing else, the takeaway: winters are great.
Yeah, absolutely. All right, so yeah, I think it's time to get started.
Yep.
Hi everyone again, and welcome to this webinar. So my name is Laurent. I'm the CEO of PacMine, and I will be your host today. For those of you who don't know PacMine, PacMine is the tech lead copilot, so acting as a system of record for all your technical decisions. And then PacMine will ensure that every line of code that you write, either by human, by a developer from your IDE, or by AI, every line of code will align with those decisions. So we provide IDE plugins and integrations with tools such as GitHub Copilot or Cursor. And we organize webinars every 2 weeks, so usually once or twice a month on tech topics. That will be the case today on engineering leadership topics as well. And so for today's webinar, I'm really excited to have Ole. So again, Ole, welcome to this webinar. This
Thank you.
webinar will be recorded. So we have a YouTube channel. If you just search for PacMine, you will find it and all the previous recording. It will be recorded. If you have any question at some point, just feel free to ask in the Q&A chat, and we'll be happy to answer it. So as I turn it over to you, Ole, we're just gonna start with a short question for you, for the audience, to get to know you better. What's your role in the organization? Are you a CTO, tech lead developer, a DevOps, a QA engineer, or anything else?
Uh,
Just let us know.
yes.
Just gonna take a few seconds for that. And Ole, you can start sharing your screen.
Oh, of course. Sorry. So, can you hear me okay?
Perfect, crystal clear.
Okay, because my microphone disconnected like 10 seconds ago. So I'm kind of
Oh,
panicking. I don't know why. I'm sure it's nothing personal. Let me see here. Okay, great. Can you see this? Yes.
yes.
Okay, awesome. Okay,
Seems
great.
like majority of the audience is DevOps, and we
Ah,
also have CTOs and
perfect.
developers.
Great people, all of them.
A great audience, yeah.
Yeah. Okay. So,
Ole, I just have
yeah.
one final question for you. So before you introduce yourself, could you share a fun fact with our audience? So we'll make sure they will not forget you ever.
Okay. So this is a harder question than you might think. So,
Ah,
what's a fun fact? So, I'm going to share that I'm a very enthusiastic virtual cyclist, which is very poignant because you have a bike on the
yeah.
background there on your And I was looking up today, I'm on a platform called Zwift, and I've done 21,000 kilometers over the last 3 years, and I've
Wow.
burned 1,200 slices of pizza. So yeah, so if you're on Zwift, you can look me up there, and we can hook up and do some virtual rides together. And as much as I love winter, I'm mostly inside during the winter, of course. In the summer,
Wow.
I'd rather be outside riding my bike.
That's pretty
Yeah.
impressive. I may add just one more thing about you, because I know you are very modest, and you are also a legend in the API space, not just in the cycling space. As a co-founder, and yeah, you created SOAP UI and that great and thriving community. So yeah, you also deserve that credit today.
Thank you, Ron. Yeah, it was actually more or less exactly 20 years ago when
Yeah.
I started building SoapUI, and that was an amazing journey. The whole API testing that kind of came out of that. So, but thanks for bringing that up. Yeah, so I've spent a lot of time on my virtual bike, which I don't know. Some would say it's sad, others would say it's fun. I'm on the fun side. But so I'm here as CTO of TestCube, a project that got started 3.5 years ago. And I'm going to talk to you about kind of testing in cloud native, because the shift to cloud native really changes how we test today, or how we see our customers testing. And then I'm going to talk, of course, a little bit about TestCube. And if there are questions, I want you to interrupt me and ask them. And Laurent, please keep an eye on the chat, because I have so many screens, I'm not sure where to focus.
Yeah.
I'm going to try to focus on the slides. But I'm always happy to answer questions as we go along. Okay, great. Let's just jump straight in. So first of all, just a high level set with shifting to cloud native. I'm sure, I mean, we had a lot of DevOps people here, so I'm sure you're aware, has really changed how we build applications, how we deploy applications, how we test applications. And I'm not going to talk a lot about how the changes have affected building. Obviously, building for applications for cloud native change the architectural context for an application that is deployed in a cloud native infrastructure. So we have to consider resilience. We have to consider the very distributed nature of cloud native applications, or the pieces, components in a cloud native application, and also something that's around how we deploy and configure our applications, which is very declarative. We've had infrastructure as code for a while now, but also shifting to even more declarative approaches with Kubernetes, obviously. And container-based architectures at the core of this, driven by Kubernetes, but of course we also have Lambda services for more lightweight workloads. Like I said, I'm not going to talk more about this. This in itself is a big topic and a huge topic, and I'll move forward. Getting more closer to what I want to talk about is testing, and testing is really something that's core to, of course, how we build code, but also how we deploy. And especially in cloud native, how we deploy software is really changing. So if you think historically, if you've been doing like a monolithic or somewhat non-monolithic microservice architecture, deployments have often been somewhat monolithic in themselves. You have one pipeline in a tool like Jenkins or whatever that does all the steps for you. It builds it and it deploys and into an infrastructure and all the steps in between of that. But what we're now seeing is, thanks to things like GitOps and event-driven architectures, is that also deployment pipelines are becoming more event-driven and asynchronous. I'm going to give examples of what I mean with that. And they're also becoming more continuous. So there's constantly a deployment wave or activity going on. It's not this, let's run the job in Jenkins and deploy. It's something that's continuously monitoring your code, your containers, your GitOps repository, and always making sure that what you've built is kind of what you also deployed in your infrastructure. And deployment pipelines also very declarative. And by that, I mean, you declare them using some syntax. It could be YAML, I guess, which is maybe the most common one, but we also see other languages being used in different frameworks. And to that end, I think I've mentioned GitOps a couple of times. GitOps is really maybe what's displacing that traditional synchronous deployment approach. and I'm going to talk a little bit more about GitOps because it is something that is really changing, and we see it a lot with our customers. That's something that people are adopting alongside of having a more traditional or old school, I don't mean that in a bad way of deploying software.
On that note, Ole, do you see, I would say, in terms of breakdown, people adopting this new approach more from scratch for new projects, or migrating existing, I don't know if legacy is the right way to say it, but a more traditional approach project to cloud migration?
I think it's a little bit of both. So it definitely, the companies we work with, they're usually large enterprises that have been around for many years. So they have a legacy application stack, which they're kind of gradually, they've maybe over the last years migrated them to microservices and to containers, and now they're shifting them to OpenShift, Kubernetes, etc. And as part of that, they're also looking to change their pipelines. And so that change could be going from Jenkins to GitHub Actions, or Jenkins to Argo, or sorry, GitOps with Argo or Flux, or it could be. It's a mixed bag, right? It's hard to just change everything, and people like to start small, so they either for a new initiative that they're doing, or they find a piece that's reasonably well contained, a component that can be migrated. So, but I feel like there's a big drive in this direction. So people are really embracing and seeing value in deploying software using a GitOps approach. So it's usually there are a couple of champions at the companies that we work with that are both driving the transition to cloud native at the application and infrastructure level, but also on the deployment. And maybe some call it like CI/CD version 2.0. That's like the internal name for how they brand this, because ultimately it's about delivering software, and GitOps is one approach to it.
And I guess for large system, we see hybrid approach, right? Where you can have part of the system that relies more on CI/CD point one, and
definitely
another part.
Yeah, definitely. And I think that's also kind of, I mean, one of the targets for for TestCube, not to get ahead of myself, is to be able to support testing and test execution both with like a legacy approach and a more modern approach. And we definitely have customers that have like 3 CI/CD solutions, right? They have the old one, Jenkins or something there. They have the reasonably new one with GitLab or GitHub, and then they have a GitOps approach, or maybe Tekton if they're going like deep into Kubernetes. So, and then trying to kind of transition depending on kind of the state and the maturity of the team and the project. They're kind of along different ways along on that path. And I think it's the right thing is to be tread slowly, because it is a big shift. I think it's a shift, not just, I mean, like many times, it's not just like a shift technically, but it's also cultural shift, right? It's similar to maybe like what you and I have in common, shift left, right? Shift left is not just about new tools. It's also about thinking differently about how you test, right? And how you build software. And it's the same thing here. It's not just about let's install Argo and we're you doing GitOps. It's about really the cultural change about how you think about your delivery and understanding the consequences of that for the product at at the high level, and the opportunities, but also the challenges that brings.
Yeah. Perfect.
Okay, so GitOps, just to kind of really, in a nutshell, is around using Git as the source of truth for the state of your infrastructure, and that infrastructure could be it mostly is Kubernetes, but technically it doesn't have to be. And so in Git, you manage all the declarative configurations for your application, for your infrastructure, and then you use a tool like Argo or Flux, which are kind of the most popular ones, to continuously monitor your Git repository and make sure that your infrastructure is in sync with the state described in Git. So it's more of a continuous process. So every time you make a change, to your Git repository, that tool will pick up that change and will try to synchronize the infrastructure to be aligned with that change. And it'll try until it kind of fails. It depends on how you configure it, obviously. So it's not like you press a button and say sync. It's something that's continuously happening. So as soon as someone makes a change, your infrastructure is updated. And the appeal here is there's multiple appeals. One is that you get all the processes and workflows that we're familiar with Git, right? With branches and with pull requests and with all the the auditing and everything else you have on Git, you suddenly get to on your infrastructure, which means, let's say your infrastructure goes down or you need to provision your infrastructure again, then you can just, here's the state, you tell Argo, provision another instance of this infrastructure based on this state. So you have a very repeatable and reproducible application environment or infrastructure. I feel like I'm repeating myself here, but so it gives that security. And then the fact that you have this fluent aspect of continuous deployment and continuous, well, we'll get to testing as part of that. It just brings it just a different and more fluent approach to deploying software.
So we have a great question here from Medhali.
Yeah.
If we want to migrate applications using GitOps with GitLab and GitLab CI and runners to OpenShift, is it more appropriate to switch to Argo CD, or is there a better solution?
So I mean, Argo is by far, so there are two kind of big GitOps reconcilers, as these are called. It's Argo and it's Flux. And they're both opinionated about, as who isn't, about what the right way to do GitOps is. So GitOps is not a technology; it's more of an approach, right? You could maybe I would definitely suggest looking at Argo first, because that's what most people use, and it's pretty straightforward to use. And then maybe reading up on the comparisons between Argo and Flux to understand what those opinionated differences are. I know that GitLab and GitHub and others are adding kind of their GitOps kind of approach on top of what they already have, but I would recommend to look at a tool like Argo alongside using GitLab. And maybe this is, like I said earlier, just because you're doing GitOps for some part of your infrastructure doesn't mean you can still continue using a more traditional pipeline for other parts, right? It's not an all or nothing approach. You can, and I would definitely suggest starting maybe with one smaller piece, or just maybe one microservice, right? Just to see, can we build the workflows for deploying that, and is everyone comfortable with that? And while you continue deploying the rest of your infrastructure or applications with a more traditional approach or a monolithic approach. And then as you progress, you'll find your way on what works for you and for your team. So hope that helps. Thanks for asking that question. Any other questions now, or should I?
No.
Okay. Okay, cool. So let's talk about testing, because testing is really something that's also deeply affected by this shift, because testing before, and I'll show you a bunch of pictures soon, was part of that monolithic pipeline. You build, you test, maybe you deploy, and then maybe you do like some test at the end to make sure. Now that these pipelines are suddenly more asynchronous and there's event driven, you need to also make sure that testing is embedded into those pipelines. So the running of your tests needs to be attuned to how you deliver software. So we've talked about shift left, and that's great, and that doesn't really have to do with cloud native, and I would propone it. There's also something called shift right, which means that we need to move our tests also maybe to use them even in production, and I'll get back to that because we see that quite often, that testing is done in production, and testing needs to be continuous, which it is almost by nature when you adopt a GitOps approach or a event-driven pipeline approach, and you integrate testing into that, because those pipelines in themselves are continuous, and so will then your testing will be. And lastly, on the testing is, testing is not, traditionally you would say testing is to validate that your application works and that it meets your functional and non-functional requirements. But what we're also seeing today is more and more testing just for validating infrastructure itself. So because the advent of GitOps, as I mentioned earlier, makes it really easy to provision infrastructure on demand, right? You have your Git repo that describes your infrastructure. You hook up Argo and say, okay, create this infrastructure in Amazon or Google Cloud or whatever cloud provider you might be using. And so ephemerally spinning up infrastructure for the sake of testing or for the sake of whatever becomes much, much easier. But then also the need to validate that that infrastructure is actually provisioned correctly. Does it have the right hardware? Let's say you're doing AI workloads and you want to make sure there are GPUs available. Does it have the right network configurations, the right secret operator, the right whatever else, right? And there's a lot of moving parts in Kubernetes, as I'm sure you know. So infrastructure testing is something that we actually see quite a lot. So people provision their infrastructure, they run infrastructure tests, then they deploy their applications, and then they run application tests. So it's two separate things. And of course, you can do infrastructure tests using just regular testing tools. If you want to, is this endpoint available? You can do a curl call, but there are also tools that are more low level, attuned maybe to Kubernetes to validate that certain resources are available.
So we're going to talk a lot about, I guess, also orchestration. And before that, you mentioned shift left, and you and I are big fan of shift left. We've worked for a few years at the same company, Smartbear, that owned Cucumber. So when it comes to this process of designing test, aligning with the business, the requirements, all that shift left approach, is the BDD, is this something that changes, is impacted by this new world, or no?
No, I think not negatively. I mean, I think shift left. By shift left, I'm thinking, creating tests as code early on in the development life cycle, maybe even doing test-driven development. I think that still is super valid. I think what changes is how you then run those tests across the deployment pipeline, right? So you can definitely continue to use BDD, Cucumber, or any other kind of behavioral framework to write your tests, and you might still want to run them early on if they're like really low-level component or unit tests. But if you use those frameworks for more like end-to-end tests or API tests or integration tests, whatever you want to call it, those tests will have to be scheduled and executed as part of your pipelines, right, later on. And I'll get back to kind of different inflection points or integration points. So maybe what I should say here is that this is not as much a change about tooling than it is test tooling. I think test tooling is much the same, right? You're still using BDD, you're still using Playwright and Cypress for your front-end tests, or Selenium. You're still using Postman or SoapUI for API tests, and you're still using K6 and JMeter or Gatling or Artillery for load testing. So that's not changed. I think there are some testing tools specific maybe to infrastructure testing, which are new. And of course, testing AI, there are testing tools, but that's not really related to cloud native. But what's changing is how we run those tests in our pipelines and how we should think about when to run them. So I think that's really the shift. But thanks for calling that out. Okay, so as I've talked about a lot, so if you look at a cloud native pipeline, and there's some graphs coming up soon, if you don't like text, before there's kind of a CI part and there's a CD part, right? So the continuous integration is where you build your artifacts, maybe today in cloud native, your container images. And during that build, you run unit tests, and you might run like component tests on that component really locally. And that, I think, hasn't really changed. And the tools you would use there are all the same. And then what has changed, and we've already touched on this, is how you then inject tests further down in the continuous delivery pipeline, like end-to-end tests, compliance tests, security tests, performance testing, etc. How you inject those tests into your pipeline. And so this could be after you're building your artifacts. Let's say you're building artifacts, pushing them into a registry. You might want to spin up an ephemeral environment, which is reasonably easy with GitOps, and run tests against that. So how do you tie in testing into that flow? Let's say you're doing progressive delivery, which like using like blue-green or canary deployments to roll out new versions of your software. How can you use tests to validate that progressive delivery is working as it should, or the component that's being delivered is actually meeting its requirements. Or then after you've deployed in a GitOps process, how do you sync in the execution of tests as part of your GitOps reconciliation process? And of course, if the tests fail, how do you roll back or do you roll back? Some people don't. It's like a fail forward approach, right? So if it fails, you raise an urgent issue somewhere, and then you wait for the fix to come. And since the pipelines are so fluent, or meant to be at least, I'm describing perfect world here, of course, that might be an approach to fixing problems instead of rolling back. And then finally, continuous testing in production, which some would say is, synthetic monitoring. I think there's a difference here. It's actually something that's pretty common, and at least from what we can see, as a way to avoid slowing down the continuous deployment pipeline. You run only baseline tests there, and then you run like the bigger end-to-end or integration tests in a production environment on a very regular basis, just to make sure that everything continues to work. You can debate if that's the right approach, but that's kind of what we're seeing.
I guess it depends on the level of risk you want to take.
Definitely. Maybe this is not what you do if you're running a bank or something like that. But good point. And I'm not saying this is like everything. It's something you'll have to weigh risk against reward and productivity and all that kind of stuff. Okay, so this picture, I think we've seen many of us some variant of a CI/CD process, and where we have like testing is kind of, you plan, you code, you build, you test, and then you release, deploy, and operate and monitor. And what we're seeing is that, I'm going to go straight forward here, is that, or we can start here, that now one injection point for test is after releasing, right? So spinning up ephemeral environments where you deploy the components that have been released and running tests against those. And like I said, with modern tools, this is reasonably easy. And there are also vendors out there that are specifically focused on building ephemeral environments for you to be able to run tests like on a continuous basis. Then while you deploy, depending on how you deploy, you could be hooking tests into progressive delivery. So if you're using a tool like Argo Rollouts, which is popular in the space, where you can either do a canary deployment or you can do blue-green deployments, there you can hook in testing tools to, as what they call an analysis, to validate that the version or component that you're progressively rolling out continues to work. And that could be both functional tests. It could also be non-functional, of course, but I think non-functional is the most common. And then after you've deployed, you might want to hook into the GitOps tool that you're using, both Argo and Flux, allow you to kind of, once they've done their work, there will be events that you can listen to or hook into to trigger the execution of tests. And then it's up to you to kind of, like I've talked about earlier, what if those tests fail? Do you roll back, which is doable, or do you fail forward and find the process? And maybe that depends on the kind of severity of the failure. And that's also something I'm sure you could automate by labeling tests and saying, if this test fails, roll back. If this test fails, it's a less severe problem. We can fail forward. Obviously, this is something that you really have to. It's easy for me to talk to slides. Getting this into place is a long process, and there's a lot of thinking and working to do and experimenting to really find what works for you and your team, and kind of like you mentioned earlier, the risk you're willing to take and the time you're willing to invest. And then finally here in production, continuous testing. I've called it out a couple of times. I'll do it again. We see this quite often. So people running tests on a schedule, and this could be functional tests, of course, just validating that, key parts of an application work, but also non-functional tests, doing like baseline load tests just to make sure, are we kind of hitting our SLAs? And of course, this is sensitive to what other load is there on the system. Security tests could be something that you run in production just to make sure that, some configuration change hasn't resulted in some security issue. So I'm not against this. I wouldn't say I'm not. I would be against if that was your only testing. I would probably say you should probably do a little bit testing earlier on as well, just to make sure. I do see this more as of a safety net to make, a catch-all kind of thing. I wouldn't rely on continuous testing in production as your main approach to testing, but who am I to judge? It really depends on.
Well, there is an even better and most risky approach, which is you don't do testing at all, and you let users test that.
Yes, super productive.
Yes,
at least for a short time.
So,
Yeah, well,
so
I'm not advocating that.
Yeah, for sure. That's the macro approach. I guess we can have and as you pointed out, that depends on every context, but you can have a more granular view or repeat almost all these steps on a staging environment. You make sure everything goes well, and then you deploy again, do the deployment in production, right?
Yeah, definitely. And so it's a great segue to the next slide. So I have a slide here showing maybe more a little bit how a GitOps driven pipeline would look like, just to kind of be more concrete. So today, this is obviously highly, abstract. So you commit your code, you have a build tool. I guess this is the Jenkins logo. Or was it Hudson? I don't remember. That checks out your repo, builds, and then pushes the artifact to your registry. It could be Docker, it could be other registries, and then this build process could then also update your GitOps repo with the maybe the version or image tag of what you've published, and then once that's updated, Argo, which is monitoring that repo, would see, okay, there's a change and my cluster is not in sync with the state described in Git, so it'll start trying to update the state of your cluster, and maybe you start with just creating an ephemeral cluster where you run tests, and then using a progressive delivery approach to then go to a staging and production environment. And this could be event driven, so automated basically, but the last step is usually manual. Usually someone has to kind of sign off before you go into production but this could also be dependent. So, and once again, kind of showing where the different inflection points for the testing activities that I showed earlier. This is where testing in the cloud native deployment pipeline would have to be injected, or could be injected, right, based on all those different steps that I mentioned earlier. And since this is often event driven, you could be listening to events emitted by the tools that you've built into your tool chain. There's a standard called CD events, which is kind of built for asynchronous pipelines, and there's also a CI/CD tool called Tekton, which is built around that kind of approach. So it's a lot of possibilities.
So we have one more question, and you
Yeah.
may want to answer it now or in a later slide. But if we use an application that enables GitOps, meaning we have a certain level of trust in the application, why should we still spend time testing the infrastructure?
By the infrastructure, well, good question. I guess we see that need when people provision new infrastructure frequently. So if you have a fixed infrastructure where you're not doing a lot of changes, retesting that maybe doesn't make sense unless you have other people involved in maintaining that infrastructure. But if you're doing GitOps properly, everything would go through your GitOps repo, and there would be nothing else in the infrastructure beside what's described in the Git repo. I would still have some kind of infrastructure test in place. Just let's say you're making change to an ingress controller or to some other low-level component that you have in your running in Kubernetes as application infrastructure for your applications. Having tests in place to make sure that, I don't know, if you're using Vault, or if you're using Istio, or what other components you might be using, making sure that they're available on the right ports, that they have the right connectivity between namespaces, that all the security is enforced, et cetera, et cetera. If these GitOps repos grow, they can get really, really large, right? I can have a super complex infrastructure, and just like in any application, it might be hard to know, if I make a change over here, is that going to have an effect on something over there? If I make a change to this service account or this cluster role, will that maybe have some adverse side effects on how people, or how applications or components or namespaces can interact? So having infrastructure tests in place to ensure that, I think, could still be a good idea. Depends on the complexity. I think if it's reasonably basic and you feel like not much can go wrong. But I think that's kind of the risk always with testing. You say, let's do it later when we think we need it, and then things happen. So I don't know. Hope that answered the question.
Yeah, good. Thank you.
Okay, let's move ahead. The software testing lifecycle is one of those life cycles that's been around for a long time. We'll just kind of show how maybe cloud native augments, or where cloud native has an impact on that life cycle. So the life cycle in itself has requirements, test planning, test case development. These first are maybe not that different from what they before. You still need to define the requirements for your application. You still need to plan how to test them, maybe keeping in mind all the things we've talked about. Test case development, I mean, building tests is still much the same. Like I said earlier, the same testing tools apply for application testing. Maybe new tools if you want to do infrastructure testing. I think when it really changes is around environment setup and test execution, because those things now are just fundamentally different. How we provision environments and how we run tests in our pipelines. And there are vendors and tools that are very targeted at these two steps. I mean, TestCube, which is targeting this step number 5, test execution, but there's a bunch of vendors out there just for provisioning and testing environments. So if you Google kind of, Kubernetes ephemeral environment, you'll get a list of vendors that do that for you. There's also something called test closure in this lifecycle, which feels like a very old waterfall-y kind of thing. We don't see that a lot because it's a very continuous flow. But once again, if you're at a bank, maybe you still do like, one release every 3 months, and then there is a phase of test closure at the end.
If we think about that's discussions we had a lot in the testing space about the persona. Ole, would you say who is responsible for what in this chain? When we think about a tester, developer, maybe a DevOps, which is a kind of new role in this environment.
That's a great question. I think a lot of the responsibility for what I've talked about here and injecting tests into your pipelines is on the DevOps persona. So, and a lot of people that come to us look interested in TestCube are people who have been tasked with how do I run my tests in my cloud native pipelines, right? We're starting to use Argo, we're starting to use Kubernetes, we're starting to use GitOps. How do I inject testing into that? And that's usually a DevOps persona. Because like I said before, the tests themselves are often the same as before, right? They're not new. And on the other side, if you look at non-functional testing, so like performance testing or security testing to validate that your infrastructure is performant or your application performant, that's also usually something that falls on an DevOps persona. So those are the people that make sure it can handle 1 million users. So then they're the ones tasked with scaling up the infrastructure or etc. So they're actually the ones writing those K6 scripts or Zap proxy or whatever tool they're using for security testing, etc. So it's very much a DevOps persona that we feel is impacted by this shift. Testers, of course, need to understand, but it doesn't. And for them, it's more of a cultural or maybe change in how to think about testing. And of course, they need to be involved in test planning. When do we run those tests? Like we said here, they can help kind of deciding which tests do we run where, right? They might push back hard on testing in production. But the ones that are ultimately tasked with setting this all up is usually DevOps.
Yep, makes sense.
Okay, cloud native infrastructure. I talked too much, so I'm gonna just short on infrastructure testing. We see this quite often. So using it for provisioning, just validating dynamically provisioned infrastructure. So I mentioned compute AI. For ephemeral testing, just to make sure that when I've spun up this cluster where I want to deploy my ephemeral instance of this application, and I want to make sure that all the components that it's dependent on are in place and configured correctly and running correctly. And that can include like just availability. It can be validating that there's network access. Maybe to the outside world. Maybe your application depends on an API somewhere else. You need to validate that you have egress rules in place. Storage, you might need specific storage. There's a lot of things you can validate for, and some people are more pedantic around this than others. It depends on how your application, of course, interacts with its surroundings. Some don't very much so. Then this won't be much of an issue.
Great, and we have a question about AI, but I know this is the next topic. I ask you to, there is AI all over the place right now. So how does that impact cloud native testing? And maybe we can spend, I don't know, just 1 or 2 minutes there. So we have time.
Sure.
I also wanted to make sure we can go through what TestCube is.
Yeah,
and
sure.
How does that answer the problem we've just discussed?
Yeah. So AI. So generative AI is definitely something that's being embraced in both in the DevOps world and in the testing world, right? So in testing, we see a lot of tools that kind of help you create tests, right? So either you point them at a website or you ask them, create a test for this, and then they'll generate the Playwright script or Cypress or whatever tool you might be using. Can also help you generate test plans based on kind of results or previous outcomes. What we see a lot, which kind of overlaps with DevOps, is using AI to analyze test failures, right? So if you deploy an application, you have 10 microservices or 10 components involved in the system under test, you run your test and the integrate, end-to-end test, and it runs for whatever time and it fails, then you're going to have a lot of logs that you need to look into, because the test failure on the end might say, okay, whatever error code you got, but you're going to try to do some root cause analysis to see where did things go wrong. And this is really where, giving an AI model all the context that you have. It could be both logs, it could be, resource metrics collected from Prometheus. It could be any kind of data that you have from the system under test. You could even give it source code repositories with the changes that were made that resulted in this failure. And it's actually pretty good at kind of hinting you and helping you pick out where you might be looking. And I think that's also, where what could be causing the failure of this test. So that's definitely something that we also see on our end in TestCube, where that adds value. But also just in DevOps in general, I think, people use it for troubleshooting clusters and being on time. Also maybe suggesting, how to solve for a problem. I think that's where AI can really be super helpful. I'm one of the people who doesn't think that AI is going to replace us anytime soon, but I think it's a great complement and a great tool to help you, with some of these very time-consuming tasks. But I mean, Laurent, you're in AI, aren't you? What are your thoughts here? Love to hear your take.
Yeah, I would definitely agree with what you say. We also see more as augmentation of developers rather than replacing them. And at least in the next 3 to 5 years, then what will happen in 10 years, I think is very hard to predict. But let's say the one trend that we clearly see so far, and there's been a great article or research paper done by Google with the DORA research program that shows that the more teams adopt AI, and they've been able to show causation rather than just correlation, the more teams adopt AI, the less stability the system has. So I guess you point about analyze logs and also look at what happens in productions and be able to correlate that with code changes and maybe increasing the test coverage is something that will become more and more important. And I think they came up with this percentage. So for every increase, a 25% increase in code interactions. So either it's refactoring, new code or new test. Every 25% increase in code interaction that is done or influenced by AI, there is a 7% decrease in the product stability.
Oh, wow.
So that's pretty massive, right? And it has been, again, it's scientific. It has been done by Google, DORA,
Interesting.
And yeah, it's like you that like winter. It's like pushing the snow just in front of you. At some point, the mountain will get so big that it will be hard.
That's super interesting. Also to kind of track, maybe, I don't know if they've built some way to kind of repeatedly do that kind of research as new models come out. Will that
Yeah.
number go down as
Mhm.
there's new models from OpenAI or etc. or what's the O3 model coming out? If that's going to change those numbers, and that's a super interesting metric to learn.
Yeah. Well, we could do a whole podcast just on this.
Yes, just on this. Well, okay, I think yeah, the last year, AI-driven analytics, of course, for proactive reporting, and we see a lot of like, if you look at tools like Datadog and New Relic and
Yeah.
Dynatrace, they're all kind of adding AI to their tools to kind of help you make sense of the data. So that's definitely something that makes sense. Okay, take a deep breath and let's talk about TestCube. Were there any other questions or anything else before I jump in? No.
We're good.
Okay, awesome. So I'm sure there's been an undercurrent to the presentation about what TestCube is in this context. So TestCube is a test orchestration and execution platform built for cloud native application development. So for the kind of pipelines that we've talked about earlier. So it basically takes any tests that you have today that you've written in any testing tool out there and allows you to inject those tests wherever you need to in those pipelines. So it could be from your CI/CD if you're doing just traditional Jenkins, GitHub Actions, GitLab, etc. But also if you're doing Argo, GitOps approach, if you're doing progressive delivery with Argo rollouts or other tool, or if you're using very event-driven deployment model with a tool like Tekton or Captain or Cargo, these all have kind of allow TestCube can hook in your test execution into any of those, right? So making sure that at least allowing you to run the tests that you have whenever needed. And then it runs those tests in Kubernetes. So it basically schedules jobs and pods, etc., for the actual test execution, which allows it to really run tests at scale. If you're running massive load tests, or if you just have a lot of tests running at the same time, or you want to parallelize your functional tests, it can do all of that. It's only constrained by your Kubernetes infrastructure, and this is all running in your infrastructure. So the costs related to infrastructure are totally your own. So it's not something that we're running in the cloud. And then since it runs all those tests, no matter how they get triggered and how they get integrated, it has a very nice single pane of glass for all the troubleshooting and reporting on tests over time. So your testers or QA or DevOps have one place to go to look at logs, to create reports, etc. No matter of kind of from which point, trigger point, those tests were executed, which just makes it very, very efficient, right? You don't have to go, oh, this test failed in Argo, I have to look in the Argo logs, or this test failed in Jenkins or GitLab, I have to go to GitLab, or I have to go here, I have to go there. It's all in one place. And then the fact that it's all in one place also makes it easy to correlate tests kind of across the life cycle of your application. And it integrates with anything you have. It's built on Kubernetes CRDs, so it works really well with low-level Kubernetes constructs. It integrates with any testing tool you have. It'll integrate with any CI/CD tool you have. So it's really not tying you into any of these tools, and it's also not asking you to rewrite your tests. Right? If you have tests that are written with Cucumber, BDD, running under Maven or Gradle, or however you can run them with TestCube wherever you want in your pipeline. And I think what we see today often is people having these Rube Goldberg machines, right? They've basically cobbled together their own test execution machine, right? So they have, there's some trigger over here, and then they've written a script in GitLab, and then they have some custom job in Kubernetes that's running with Flux, and then they have some, third-party test scaling tool, and then they have kind of to adapt this for K6, for Postman, for Playwright, for et cetera, and then maybe they use another third-party reporting solution, and it just becomes something that multiple engineers have built over the years, and it becomes very fragile and very don't touch because it's working, but it in the end it just slows you down. So this is really kind of the scenario that we go in and replace, where you have a standardized framework for running tests and for running tests in these kinds of pipelines.
I think this image tells a lot. Just one quick question. What would you say is the trigger let's look at a solution that can really help us be like the conductor, right? For our infrastructure testing, or for our testing, not just infrastructure. And yeah, when I add a new rope, I may break everything. So what's that rope, that trigger?
I mean, the rope today, what we see on TestCube is Kubernetes and maybe GitOps specifically. We see a lot of people adopting Argo or GitOps methodology alongside, the non-GitOps way, and Kubernetes in itself. So a lot of people just Google, how do I run my Playwright test in Kubernetes, or how do I run Postman from Argo CD? That's kind of, it's very tactical. They're solving this thing here, right, or this thing up here, and then as they discover TestCube, they realize it could actually help us replace all of these things, right? And then over time, like any tool, right, you don't immediately replace everything. You start kind of exchanging one after the other. Okay, does it still work? Does it still, you kick the tires and let's do some reporting? And then over time, this can take months to years. You've replaced this entire thing with a more holistic approach to test execution.
Great.
How are we on time?
We're good.
Oh, I'm good. Okay, great. I'm almost done. So TestCube, we break down test execution into 5 steps. So it's about defining how to run your tests. And we've built our own workflow engine that's really highly optimized for running tests specifically. It's about triggering tests. So like we've talked about a lot, right? How do you trigger your tests? Is it from CI/CD? Is it from GitOps events? Is it on a schedule? Is it through CLI, API, some other integration, right? So that's something that you can do. Scaling, how do you scale your tests both horizontally and vertically? And that's something we can do really well thanks to Kubernetes. So it's not like we built our own scalability engine. It's just that we're leveraging all the niceties that Kubernetes brings to the table. Troubleshooting, since we pull in all the logs and everything from the tests that we run into one interface, and all the, let's say you're running a test with, well, you said Maven, Cucumber, all right, that might generate a report. We pull in that report as well. So you have both kind of tactical reporting for a specific test run that could be produced by the tool itself, like, JMeter, K6, Playwright, these tools all create great reports in themselves. But then over time, we obviously have all the test results of all the tests that you've ever run. And so you can really dig into pass-fail ratios. How many tests are we running? What about this team? What about this component? What about, however you want to slice and dice your data, you can use that then to make more strategic decisions about testing initiatives. We need to do more testing of this. So this team needs to do more testing or less testing. It's also about, we get asked this a lot actually, is, can you help me reduce test execution costs, right? And so there's 2 aspects to this. One is, since we're running tests in your own Kubernetes infrastructure, that in itself is usually a cost saver, because today people are often running tests maybe in GitHub or GitLab, or they're using a third-party test execution like Sauce Labs, Browser Stack, Lambda Test, etc. And those are both very expensive as you scale, and they're also not really built for this kind of cloud native approach to deployment pipelines or testing pipelines. Yeah. So sorry. So that around cost, we also kind of help you analyze resource consumption of your tests, so you can easily identify tests that maybe have too much resources at their disposal, but also tests that are under, they need more resources to be more efficient, right? This test might be really, really slow because it just has too little memory, and that's something we can help you with. And we, of course, we integrate with Prometheus and Grafana and all these tools that are prevalent in the Kubernetes ecosystem. So really trying to play nicely with all of that.
That's very important because every company now is looking at savings money, and
Yes.
I have some real life example of clusters that were up for testing. You just use them, let's say, a few hours a week, but when you look at the bill, you say, "Wow,
Yeah.
holy moly!"
Exactly.
Yeah, that's
So that's definitely something. There's money. There's money to be saved.
yeah.
We're also looking to integrate with OpenCost, which is a framework for kind of predicting costs for your test workloads running on different providers. So there's a lot we can do in this space. Okay, just finally, we're not going to have time for a demo. So if someone wants a demo, please reach out. I'm happy to do one. But just at a high level, the architecture. So TestCube has two main components. There's a control plane that, and there's an agent. And the agent is what you deploy in your cluster to run your tests. The agent is open source. It's MIT licensed. You can run it on its own, and you deploy that in your clusters, and it'll run tests for you in that cluster. And then there's a control plane that you also deploy in your infrastructure. We can also host it in the cloud for you, but we usually, most of our customers run everything on-prem. And that control plane then allows you to manage as many agents as you want. So let's say you might have multiple agents for each, either production, dev, staging environment, or different agents for different teams, or you create agents dynamically for ephemeral, like we talked about earlier. So this kind of ties in with all of those kind of different needs that we see. And then there's a bunch of functionality in the dashboard, even some AI in there to help you troubleshoot your tests, that kind of stuff. So a lot of goodness there. If you go to testcube.io, you can, get the docs will tell you how to get started with open source, and the website will help you get started with just getting this started in your infrastructure. So
Yeah, maybe Ole, if you just want to add your email, I don't know.
Oh,
That
sure.
in the chat in case people.
Oh, I didn't. Yeah, it's not there. I'm sorry. Of course, I'll put it here.
Yeah, I was checking on the last slide, but it's not there. Great. And yeah, is there any question for Ole before we wrap up? Yeah, perfect. Thank you, Ole. I have one more, maybe one last question from another age, but there is everything here is obviously, I would say, fully automated. Do you see any reason why at any of those stages we've seen we should have a kind of manual test execution? Or
oh, that's a great question. Yes, thank you for bringing that up. So as much as we love automation and all that stuff, so I think exploratory testing and manual testing is still super important to kind of continue, find those outliers. Testers are super smart usually, and they can think critically about how your application works. If they understand how the infrastructure is set up and configured, they can also really try to find pain points and corner cases where the application maybe doesn't behave as it expected. So I definitely would recommend to continue to do exploratory testing or manual testing alongside all of these automated activities. This will never replace, I think, automated testing will never fully replace the need for like an exploratory testing approach. So it can go a long way, and it can free up a lot of time for exploratory testing, which is why I think it's good. But thanks for asking that. You're totally right. I hope I'm not giving you the impression that this is all your testing should be automated. You should definitely continue. Just kick the tires manually and see what you find.
So that's an and, no or.
That's an and, yes, exactly. Thank you.
Great, awesome. Thank you very much. So no more questions. So I guess, yeah, that's time for us to wrap up. We have a final question, final poll for you, just to get feedback on this webinar. And as you take time to answer, I would really want to thank you. Thank you, Ole. As I said, you are a legend, so that was really an honor to have you on this webinar. And also thank you to the audience. As I said before, this webinar is recorded. You will receive a link to the recording. And yeah, continue to follow us for more great stuff in the future.
Yeah. Thank you so much, Laurent, and thanks everyone for listening. It's been a pleasure talking.
Perfect. Thank you. Bye-bye.
Thank you. Bye-bye.